N identical cells are connected to form a battery. When the terminals of the battery are joined directly, means short-circuited, current I flows in the circuit. To obtain the maximum value of I, all the cells should be joined in series or in parallel or in some other form. So before proceeding in this question, let me tell you some standard concept. The first one, there is a series combination of batteries. What we do in such a case, that all the batteries are connected one after another. Okay, and suppose the whole combination is connected across a load resistance capital R, and there are N cells connected like that. Okay, so internal resistance is small r, E is the EMF of each cell. So all cells are identical. So what should be the current flowing in this resistance in this case of series combination? If there are N cells, we can see that total EMF of the circuit has become NE, and total resistance you can see is capital R plus N times small r. So this will be the current in the circuit when these cells are connected in series. And in this case, since it is short-circuited means there is no load resistance, means capital R is equal to 0. So capital R equal to 0, that means I in this case has become equal to E divided by small r. That means it is same as the current drawn from a single cell. So in this case, in this given situation, when the combination is short-circuited means load resistance is 0, or we can say that load resistance is much smaller in comparison to the internal resistances of the battery. So in such a case, series combination is not preferred. Okay, so now if we talk about the parallel combination, then there is one load resistance and all the cells are connected in parallel to each other like that. Internal resistances are there, their EMFs are, so all are connected in parallel. Then we can see that effective EMF between these 2 points will be same as the single cell EMF. I is the current, suppose in this case, second case of parallel combination, then I will be equal to E divided by what? Capital R plus R divided by small n, because these resistances are connected in parallel with each other. So here you can see, if capital R is equal to 0, then in that case I is n times E divided by small r. So here you can see that current flowing in the circuit when capital R is 0, which is equivalent to short-circuited. That means these 2 points are directly connected to each other. In that case, we can see that current is equal to N times the current, approximately the current from a single cell. So parallel combination must be preferred in such a situation. So all the cells should be joined in parallel to get the maximum value of the current, and that maximum value of the current will be N times, approximately the N times the current from a single cell. Okay, so option B will be correct.